Hey everyone, and welcome. Today we're going to pull back the curtain on something we use every single day, but maybe don't think about too much. Digital storage. We're going on a journey from the little drive in your pocket all the way up to the gigantic systems that basically hold the entire internet together. So let's dive right in. Think about it. You click save a dozen times a day. It's just muscle memory at this point, right? But have you ever actually stopped and wondered, what is happening in that split second? Where does that file, that photo, that whole project, where does it really go? It's not just disappearing into thin air. There's a real physical process happening.
And the answer to that question is something called secondary storage. It sounds a little technical, but all it really means is the physical device where your data is going to live for the long haul. You can think of it as your file's permanent address, whether that's a chip inside your phone or a massive server farm thousands of miles away.
Now here's something that trips a lot of people up. It is absolutely crucial to understand that storage is not the same thing as memory, or what we call RAM. Memory is like your desk. It's the workspace where you have all your stuff out while you're actively working on it. It's super fast, but it's also temporary. The second you turn the power off, poof, everything on the desk is gone. Storage, on the other hand, that's the filing cabinet. It's where you put things away for safekeeping even when the power's out.
Okay, so let's get into the hardware. We're going to start with the absolute classic, the workhorse of the digital age, the magnetic hard drive. You know, the HDD. For decades, these things were in pretty much every computer, and if you understand how they work, you'll get the foundation for everything that came next.
So if you were to crack one of these open, what you'd find is basically a marvel of mechanical engineering. It's got these super smooth metallic platters. They look kind of like a stack of tiny mirrors, and they are spinning at an insane speed. We're talking thousands of revolutions per minute. It's on the surface of these spinning platters that all your data gets physically recorded. So you've got all this data on a spinning disk. How on earth does a computer find one specific file in a fraction of a second? Well, that's where formatting comes in. When you format a drive, you're essentially drawing a map on it, dividing the disk into this incredibly precise grid of tracks and sectors. Every single piece of data gets its own unique address, just like a street and a house number, so the computer knows exactly where to look. So how does it actually write the data? Well, the surface of that platter is coated with millions of tiny magnetic particles. A little arm with a read/write head on the end swings over the platter, and to create the ones and zeros that make up your file, it uses a tiny electromagnet to flip the polarity of those particles, pointing them in one direction or the other. It's literally a physical landscape of microscopic magnets. And this is where it gets just mind-blowing. That read/write head is flying over the surface of the platter at incredible speed, but, and this is key, it never actually touches it. The gap between the head and the spinning disk is smaller than a single particle of smoke, way thinner than a human hair. It's an incredible feat of engineering, but it also leads to a huge problem. Yeah, that incredible precision is also its greatest weakness. If even one tiny speck of dust gets inside that sealed case, it's like a boulder on a highway for that flying head. It can cause the head to literally crash into the platter, scraping the magnetic material right off and completely permanently destroying your data. It's called a head crash, and it is catastrophic. That mechanical fragility, that risk of a head crash, that's what really pushed engineers to find a better way. And that brings us to the solid-state revolution. The game changer here is right in the name. Solid-state drives, or SSDs, have zero moving parts. None. So, let's put them head-to-head. How do they stack up? Well, because there are no spinning platters or moving arms, SSDs are just ridiculously faster. They're more durable, they're silent, and they use way less power. For a long time, the big trade-off was the price. Your classic magnetic hard drives give you a lot more storage for your money, but that gap has been shrinking year after year. And you know, the tech behind these SSDs, it's called flash memory, isn't just for your main computer drive. It is literally everywhere. It's the same technology that's in that little USB thumb drive on your keychain, the memory card in your camera, and of course, the storage that's built right into your smartphone. Okay, so we've talked about the devices you can actually hold in your hand. But what about all the data that just lives out there somewhere? This, of course, brings us to the cloud. We all talk about it, we all use it, but what is it, really?
You know, when you strip away all the fancy marketing terms, the concept of cloud storage is actually super simple. It's just a storage device, a bunch of hard drives or SSDs, that's located somewhere else and you access it over the internet. So when you save a file to the cloud, you're really just saving it to a super powerful computer called a server that's sitting in a massive warehouse-sized building we call a data center.
That's it. It's just someone else's computer.
So why do we use it? Well, the advantages are pretty huge, right? It means you can get to your files from your phone, your laptop, your tablet, any device, anywhere you have an internet connection. It makes sharing big files with people a piece of cake. And maybe most importantly, it acts as a constant backup. If your laptop gets stolen or your phone takes a swim, your data is still safe.
All right, let's zoom out one last time. Let's go big. How do the giant companies that basically are the internet, we're talking Google, Netflix, Amazon, how do they store the just unimaginable quantities of data they deal with every single second? They use systems built for insane scale and total reliability. You see, when you're dealing with thousands of hard drives, a drive failure isn't an if, it's a when. It's going to happen, a lot. That's why they use a technology called RAID. It's a clever way of linking multiple physical drives together, so if one of them dies, the others have a copy of the data and the whole system just keeps on running like nothing ever happened. It's a data safety net.
Okay, now imagine you take one of those super reliable RAID systems. You put it in a simple little box and you plug it into a network. What you have now is a NAS, or Network Attached Storage. Think of it like a central high-speed filing cabinet for an entire office. Its one and only job is to save and serve up files, which makes it incredibly efficient for teams who all need to access the same pool of data.
But for the absolute giants like Netflix or YouTube, even a NAS isn't going to cut it. They use something called a SAN, a Storage Area Network. Now, this isn't just a device on the network, the storage is the network. A SAN is an entire, separate, super high-speed network made up of nothing but interconnected storage devices. This is how they can provide what feels like instant access to petabytes of data for millions of users at once. This, right here, is the real backbone of the cloud. So there you have it. From the spinning platters inside an old desktop PC to these planet-spanning networks that power our digital lives, that is the incredible journey of digital storage. But I'll leave you with this final thought. The total amount of data in the world is doubling, roughly every 2 years. With that kind of exponential growth, what comes next? What kind of crazy new technologies are we going to have to invent just to keep up? What do you think the future of storage is going to look like?